In this last proof, we have a different situation entirely. We have, excuse me, we have two parallelograms given, and we're trying to prove that two triangles are congruent. To prove that triangles are congruent, recall that you're going to use side, 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 side angle, side, and so forth. So let's see what we're given here. Start with our givens, ACDF and ABDE are parallelograms. And that, of course, is given. When you're trying to prove something about the triangles, what you want to do is determine which parts of these parallelograms are also parts of the triangles. So in this case, maybe they share some sides, or maybe they share some angles. In other diagrams, like take a parallelogram and draw in its diagonals, when you're proving those triangles are congruent, maybe you want to use the property of parallelograms that says that the diagonals bisect each other. But the options that you want to use are based on what you see in the problem. So let's outline this first parallelogram, ACDF, and see what it tells us. Which parts of that parallelogram are also parts of the two triangles we're trying to prove congruent? And we can see here that the triangles share a side, each of them share a side, with the parallelogram. So looking at triangle AFE, we can see that it shares this side with the parallelogram. And in triangle BCD, they also share this side. Now it happens to be that those two sides in that parallelogram are opposite sides, which makes them congruent to one another. So here, segment AF is congruent to segment CD. I'm not really worried about the other pair of opposite sides because they're not sides of the triangles. Opposite sides of a parallelogram are congruent. All right, are there any other parts in that pink parallelogram that are also parts of the triangles? What you're looking for, look for sides that they share and look for angles that they share. In this case, there's a pair of angles that they also share. Angle F is interior for the parallelogram and for triangle AFE. And angle C, it's the opposite angle of angle F, is also an angle in both the triangle and the parallelogram. So in step 3, we'll state that angle F is congruent to angle C because the opposite angles of a parallelogram are congruent. And that gives us two congruent parts in our triangles. And that's all from that first parallelogram that we were given. Now we're going to go to the second parallelogram, ABDE, and see what it tells us. There. All right, so first thing I see is that the triangle AFE and the parallelogram I've just outlined share a side. They share side AE. And triangle BCD shares segment BD with that parallelogram, which makes those a pair of opposite sides of the parallelogram that happen to be parts of the two triangles. So because they are opposite sides, I'm going to add them up here to step 2. Segment AE is congruent to segment BD. I can only add that in there because they're both directly from the given. The first statement in number 2 came from the parallelogram we outlined in pink, and the second statement in number 2 came from the parallelogram we outlined in green. Now, looking at that green one, all of the interior angles in that green parallelogram are not interior angles of the triangles. That does not mean that they can't be useful. There are ways that those interior angles of that green parallelogram can help prove something about the triangle's angles, even though they're not the same angles. And you'll see how that plays out in just a minute. Now, if you look at what you've now got 3 congruent parts. And typically, that's where we'd start to say that our triangles are congruent. However, in this case, as you look at the three congruent parts, you can very quickly see that the triangles can't be proved congruent because the two parts make an angle side-side relationship. And you cannot use angle side-side to prove two triangles are congruent. So what that implies is that we have to figure out another way to prove the triangles are congruent. I need another congruent part to prove the triangles are congruent to each other. For example, if I could prove that segment FE is congruent to segment BC, then I could say the triangles are congruent by side, side, side. If I could prove that angle FAE here is congruent to angle CDB there, then I could use angle side angle, which I see here, angle side angle, or I could use side angle side. If I were able to prove that this angle at E and that angle up there at B, if I could prove those were congruent, then I could use angle side angle, I could use angle angle side. But somehow I have to have another pair of congruent parts. Now, if you're going to prove that segment FE is congruent to segment BC, you'll have to use the segment addition postulate. And there are multiple proofs out there on YouTube and various other places where you can see people use the segment addition postulate to prove those two are congruent. I want to show you an alternate way that you can do it using the congruent supplements theorem, which you may not recall. That's why I'm bringing it up now. That will allow us to prove that those last two angles I marked, the ones I marked with an X, allows us to prove those two angles are congruent. And it deals with a pair of opposite angles in the green parallelogram. Specifically, I want to use this angle at E, angle AED, and this angle with a vertex up there at B, angle ABD. I know that they are a pair of congruent angles because they are opposite angles in that green parallelogram. So because they are opposite angles, I'm going to add them here with my other pair of opposite angles. Now, how is that helpful? Remember I said I was trying to prove something about the two angles that were marked with an X. The two angles that are marked with an X, along with the two angles I just marked in green, they each form a linear pair. And recall that linear pairs have a set value. They have to have a sum of 180 degrees. In this case, I know what my angle pairs are. Angle FEA is supplementary to angle AED. That's this pair here around point E. And I know they're supplementary because the linear pair postulate says if two angles form a linear pair, then they are supplementary. And that provides my reason for step 4, linear pair postulate. If two angles form a linear pair, then they are supplementary. Now I have another pair of linear angles up at point B. So angle ABD, add this here to that same statement, ABD is supplementary to angle CBD. That's the one that's marked with the little X. The congruent supplements theorem says if two angles are supplementary to the same angle or are supplementary to a pair of congruent angles, then they are congruent to each other. In this case, based on what we have in step 4, we know that angle AED and angle CB, no, make sure I wrote that right. ABD, there it is. That underlined the wrong one. That angle AED from step 3 is congruent to angle ABD. Now, if those two angles are congruent, that tells us since angle FEA is supplementary and angle CBD is supplementary to a pair of congruent angles, that allows us to conclude that angle FEA is congruent to angle CBD. They are two angles that are both supplementary to a pair of congruent angles. The congruent supplements theorem. The nice thing about this theorem is that it allows you to step or sidestep some of the algebra that can be involved in a proof. If I went to prove the congruent segments that I mentioned before with the segment addition postulate, it's going to add some length to your step because you've got to do all those algebraic steps. So in this case, we've now proven another pair of angles are congruent. We'll go ahead and mark those in my diagram, like so. And now we've got multiple options for how we want to prove these triangles are congruent. We could use angle, angle, side. We could use, what else could we use? Oh, I guess that's our only option. We don't have side, side, side. We don't have side, angle, side. We don't have angle, side, angle. So in this case, for 6, the triangles BCD and EFA are congruent by angle, angle, side. And it doesn't matter which of those two congruent sides you're looking at. Either way, it's an angle, angle, side relationship. And that takes care of that last proof.